Hello guys, today we'll be starting our next unit on ratios. So as usual with these videos, make sure you have something to write with and write on, and you should be taking notes along with these videos. They will be really important to reference and be a really great tool for you throughout this unit. So please make sure you are taking notes, it is a requirement. And we will go ahead and move on. So I'm just going to give you a reminder that you must take notes while watching this video. They'll be a great resource to you. We are starting with two sections today. We are going to work on ratios and ratio tables. And today's essential question is, how can you represent a relationship between two quantities? And we will explain that right here on the next slide. All right, so let's talk about what a ratio is. And kind of like our essential question had stated, a ratio is a relationship between two quantities. So how can we describe a relationship between two quantities? By using a ratio. And there's different types of ratios, and I will describe those different types to you right now. So we have something called a part-to-part ratio. And that describes different parts of something. So part to part ratio, as it sounds, it describes different parts of something. So for example, when we look at this picture down below right here, you see calculators and pencils. So if we were creating a part to part ratio, here we can say that there are two calculators for every 6 pencils. So our part-to-part ratio there would be 2 to 6. So a part-to-part ratio just describes the different parts within the ratios. Other than that, we have something called a part-to-whole ratio. And similar to what our other name said, the name describes this as well. So this describes, rather than the part compared to the part, it describes the parts compared to the whole. So for example, here we can say that there are 2 calculators for the whole set for every 8 in the set. Would you agree? When we count them up, there are 1, 2, 3, 4, 5, 6, 7, 8. So there's 2 for every 8. And we can also make a part-to-whole ratio, of course, for the pencils. And in that case, there would be 6 pencils for every 8 items there as well. So we would have the part-to-part ratios of 2 to 8 when we're talking about calculators, and the part-to-part ratio of 6 to 8 when we're talking about pencils to the whole there. And then the last type of ratio would be whole to part. It would be the same idea, but just reversed in order. So it would be the same thing, except backwards. So there would be 8 of the whole for every 2, and then 8 in the whole for every 6 when it comes to pencils. And order definitely matters when it comes to ratios. Ratios are basically types of fractions, and we know the fraction symbol literally means divided by. So when we're dividing, we know the order matters. In ratios, the order absolutely matters, and we'll talk about that some more in our next slides. All right, so make sure you are writing this down. This is an idea of what ratios are. All right, now let's talk about using tape diagrams to help us solve ratio problems. So I'm going to read out this example, and I'm going to introduce you guys to tape diagrams. I think you're really going to like them as a resource to help you solve ratio problems. So this one says, the ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. So we know that this is going to be a key concept right here. 5 to 3 is the ratio. And remember when I talked about the order mattering? So in this case, how do we know which one's our friend's and which one is our monthly allowance? It just goes in the order as it's stated in the problem. So in this case, it says the ratio of your monthly allowance to your friend's is 5 to 3. That means yours would be 5. And I am going to represent yours in red. So I'm just going to draw a little diagram with 1, 2, 3, 4, 5 boxes. And then our friends is 3. So I'm going to draw one with 3 boxes as well. And I will label this as yours. And I will label this other one as friends. All right, so let's continue reading. The ratio of your monthly allowance to your friend's monthly allowance is 5 to 3. The monthly allowance is total $40. And that's the total. How much is each allowance? So what tape diagrams do, they're a really great resource. They kind of allow us to visualize the problem. That way we can understand how to set it up and then solve the ratio values. Okay, so in this ratio, our goal is to determine how much each allowance is. And we know the ratio for each one, and then we know the total. So for tape diagrams, what you're going to do is you are going to create a tape diagram for each part of the ratio. And the really important part here is just to know exactly what the question is asking. Because in the previous slide, we talked about different types of ratios. There's a part to part, there's a part to whole. So we can't always assume we're looking for the same thing. It just depends on what's asked in the particular question. Like for example, in this question, we know that we want to find out how much each allowance is. We know what the ratio is, and then we know the total. So in this case, since we know the total is 40, we know that this whole ratio is going to be represented by 40. So the way we can solve for each box is we are going to actually add those ratio boxes together, because we know ratios, it's going to be the same in each of those boxes. So we're going to add those boxes together, and then we are just going to divide it by our total in order to find what each part of the ratio is equal to. So I'll kind of describe exactly what I mean. So we're going to count these boxes. So there's 1, 2, 3, 4, 5, 6, 7, 8. And now we're going to take our total over here, and we are going to divide the total by number of whole ratio. And the reason this time it's whole ratio is because this is what this question asks for. But it won't always be whole. It just depends on the particular question. So in this case, we'll do 40 divided by 8. And if you know your math facts, you would know that that equals 5. But if you don't, then you can use a calculator. And of course, that will aid you in knowing that equals 5. That means that each part of this ratio is equal to $5. And anytime we are determining ratio boxes, guys, everything within has to be the same. If it's not, then you're not working with a proper ratio. You made a mistake somewhere. All right, so now that we know each of those boxes is equal to $5, we know that how much each allowance is total. We would just have to count them up or multiply or add. So in this case, 5, 10, 15, and our friend made $15. And in this other case, we have 5, 10, 15, 20, 25. We made $25. And of course, we can add those together to make sure they equal to 40, which we know that they do. And then another way you can check this is we can always simplify the fraction. So ratios are actually the same as fractions. Equivalent ratios would be like simplifying a fraction here. So in this case, 25 over 15, if we were trying to simplify this and find a common factor, we would know we can divide these both by 5, and that would be equal to 5 to 3, which that was our original ratio. So we know we did this correct. All right, so that is our first strategy of using tape diagrams to solve for a missing part of a ratio. All right, what I quickly wanted to show you is the difference between a tape diagram depending on what is asked in the question. In that last slide, if we flip back to it, we know in this case they were asking for how much each allowance is, and we knew what the total between the ratios was. But in this case, not the same is true. It says the ratio of girls to boys is 5:4. So I'm just quickly going to draw that as well. I'm going to draw one with 1, 2, 3, 4, 5, and this would be girls because it starts with girls is 5, and then boys is 4. 1, 2, 3, 4, and this one represents boys. And in this case, the question says there are 16 boys. How many girls are in the class? So we're trying to find out girls. Now in this case, we're not going to do the same thing and talk about the total and then divide. And the reason why is because we already know how many boys are here. So in this case, we just have to break up this number for boys only because we're only talking about boys. So if we know that there's 16 boys, and in this case the ratio is 4, we would just divide it by this 4 because we want to determine how much boys is each part of that ratio. So 16 divided by 4 would leave us with 4. That means we know each box is equal to 4. And remember, our ratios will always be the same. That means the girl boxes are also going to be equal to 4. And now we can find out how many girls are in the class. So we knew that 16 boys were in the class, and now we do 4, 8, 12, 16, 20. That means 20 girls are in the class. And once again, if you want to check it, these are the same as equivalent ratios. It means we simplify just like we would simplify a fraction. So 20 over 16, we just want to make sure that that equals to 5:4. So in this case, a common factor would be 4. We can divide these both by 4, and we would get 5/4, which, like I said before, is equivalent to our ratio, which means we know we did this correctly. All right, let's talk about some other different strategies. So completing ratio tables. Ratio tables are another way to solve ratio problems. So in this case, we're given 2 ratio tables because I just wanted to show you different ways you can find the pattern in a table. So you're going to find the pattern in a ratio table by multiplying when values increase, or of course we can do the counterpart, which is or dividing when values decrease. And I want to explain kind of exactly what that means. So it's all about patterns when we're completing ratio tables and we want to identify them. But what's really important is we either have to go by multiplication or division. We don't go by addition or subtraction here. Probably in elementary school you did, but in this case, we have more difficult patterns. It's not just going to be adding a few. We want to determine multiplication. So for example, in this case, you think, okay, how do I get from 1 to 2? What do I have to multiply 1 by to get to 2? And we know 1 times 2 would be 2, right? So in order to copy that same ratio, these are equivalent, we have to do the same thing. Oops. We would have to do the same thing to this side. So if we multiplied that to 2, we'd also have to multiply this by 2. And of course, we know 3 times 2 would give us 6. So we just filled up that ratio. And now we have this given value here on the bottom. So we have to think, okay, how do we get from 3 to 9? What do we have to multiply by to get from 3 to 9? And of course, we know 3 times 3 equals 9. Therefore, this pattern on top is going to be the same as well. We're going to multiply 1 times 3, and that would mean this is 3. And I want to show you how those are all equivalent to each other. So we have 1/3, 2/6, and 3/9. So this would actually both show us the process of simplifying to get to 1/3, which would be the simplest one. We know that these both two would have the common factor of 2. When we simplify those, we get to 1/3. Oops, I don't know why that disappeared. These both would have the common factor of 3. And when we simplify those both, we would also get 1/3. And you could see all of those are equal. Now with this diagram, obviously it's the same thing, but I wanted to show you how you use division when they're decreasing. So if I was going this way, I could say, okay, how do I get from 2 to 1? And of course, I would have to divide by 2. That means from this one to this one, I would have to do the same thing, divide by 2. So what number divided by 2 would give me 3? Of course, it would be 6. And then same thing, if I was going backwards again on this side, what do I divide by to get from 9 to 3? I'd have to divide by 3. And same thing here. What would I have to divide by to get to 1? And of course, in this case, it would have to be 3 divided by 3 to get to 1. All right, so I'm showing both processes. Typically, multiplication would be the more popular one, but just so you know, it's the same as using division backwards. All right, so that is how we complete ratio tables. Another example, another strategy you can use to solve ratio problems. All right, proportions. This is a final strategy to solve ratio problems, and I'm going to show you exactly how to do this. So this one says you are listening to music on Spotify. The ratio of pop songs to rock songs you listen to is 5:4. You listen to 40 pop songs. How many rock songs do you listen to? So this time, I know we learned tape diagrams. I know we learned ratio tables, but this time we're going to use proportions, and I'm going to show you exactly how to do that. So let's see. The ratio is 5:4. So the way we do this is we actually almost set up fractions with an equal sign to each other, but we are going to set up our missing value as whatever we're looking for. And we're always going to line up what we know. So for example, 5 represented that first one, so it would have been pop. And 4 would represent the second one, which would be rock. Okay, so we're going to line up what we know. So this says we listen to 40 pop songs. Pop we represented in blue. And so I'm going to line that up with 5. Because these both represent pop. And what we're looking for, the question asks us, how many rock songs do we listen to? And that's what we're looking for. So I'm going to represent that here as X, which is just a variable. It's an unknown value that we have to solve for. Okay, so our next step here is we are just simply going to cross multiply, and that is how we solve for proportions. So we're going to multiply our diagonals here and our diagonals here to set up an equation that we will continue to solve. So in this case, we are going to do 4 times 40 is equal to 5 times X, and X is just a variable that represents an unknown value. All right, so 4 times 40, we would get 160 equals, and my 7th graders would know you multiply 5 and X at the same time to get 5X. And then this final step, anytime we see we're trying to solve for X here, once again, 7th graders would know you use inverse operations, which is the opposite. And since this is 5 times X, the opposite of times X is divided by. So we would divide both sides by 5. And our answer here would be that X equals, and if you needed to, you can use a calculator to aid you here. You would just do 160 divided by 5, and that equals 32. So that means we listen to 32 pop songs. And once again, you can check that ratio to make sure it makes sense. So if we plugged in 40 to 32. We want to make sure that simplifies to 5/4. And let's think about a common factor here. And let's say that 8 is a common factor, which it is. And 40 divided by 8 would give me 5. 32 divided by 8 would give me 4. So I know that that is correct. All right, so that's a final strategy for you. And now that we have all those strategies, let's go ahead and use the different strategies to go ahead and solve. All right, so this says a store sells 2 printers for every 5 computers. The store sells 40 computers. How many printers does the store sell? So we're going to try all of our strategies on this, just so you guys can kind of get the idea of which ones you like better. So I'm going to draw a tape diagram to start. So 2 printers for every 5 computers. So I'm going to draw a tape diagram for both of those. All right, so this first one is going to represent printers. That second one is going to represent computers. I'm just going to abbreviate. The store sells 40 computers. All right, so in this case, we are specifically talking about the computers. So we know we sell 40 computers, and we want to know how many printers are sold. So in this case, we're only going to count up the computers box because that is what this problem is talking about. So there's 1, 2, 3, 4, 5. So in order to determine what each box is worth, we're just going to divide by 5. 40 divided by 5 is going to give me 8. That means I know each of these boxes is equal to 8. And remember, if that's true, that means this is also, because it's a ratio, which those all have to be equal. Therefore, I know how many printers the store sold, and the store sold 16 printers. So that would be our tape diagram. All right, now let's go ahead and use, I'm going to draw a table. So I'm going to represent this pretty easily just by saying, let's see, P for printers and C for computers. And we know that the ratio is for printers 2 and for computers 5. And then we knew that they sold 40 computers. So from here, kind of similar to what we just did there, we would just have to develop the pattern. So how do we get from 5 to 40? We know that we'd have to multiply by 8. Therefore, here we would have to do the same thing, times 8. And we know 2 times 8 would give us 16, which also would tell us it's 16 printers. All right, so that is how we would use the tables for that. And then my very last strategy would be proportions. For proportions, we'd actually set up the exact same thing. So we would just set up what we know. We know that there is 2 to 5 when it talks about printers to computers. And remember, we set this up with the same thing. So we know computers, which would be set up equal to the 5. And same thing, we would want to solve for our missing value. So in this case, I'll actually name it as P for printers. And then from there, we cross multiply. So we'll take a look at our diagonals. We're cross multiplying. And so that means we know 2 times 40 is 80 equals 5P. And 5P is 5 times P. We would take that final step and divide. And 80 divided by 5, we would know that P equals 16. All right, so there are 3 strategies you can use to solve ratio problems. As always, you guys are free to use whatever strategy works best in your brain, although we are going to explore these a little bit deeper. That way you can gain more experience to see which ones you like better. All right, thanks for taking notes. Make sure you keep these somewhere safe because they will be very valuable to you over the next few weeks. All right, thanks.